I have a second channel, Cube Comp MTDX.
Hey everybody. So recently I went on Amazon to look for some extra batteries for my DB powered D2 action camera. The camera itself is a knockoff of probably the SJ Cam series action cameras, which are a knockoff of GoPros. And it's very similar to the sports camera that I had last year that was a utter piece of junk. But this camera that I have now is fantastic, but it only has one battery. And I need to order some more batteries, so I got these. And one thing that stands out about them is they claim to be 1350 milliamp hours. Okay, so the battery that came with the DB power camera is rated at 1050 milliamp hours, and it did probably run 900 or so milliamp hour range, at least from my test in the previous video. So I'm curious to see if this rating here is honest. So let's go and unbox the batteries and have a look at this nice mark on the packet on the box there. Must have happened during shipping. This was packed in a larger box with just a few of those airbags, which I'm not a fan of. So you get a micro USB cable, a rather short one, but it's convenient, I think. You get a little micro USB cable. You get this little charging station, which plugs into, of course, USB power. You can plug it into, let's say, a computer, or more recommended, a power bank, or a USB phone charger of some sort, something that can supply a good bit of current for faster charging, because this thing can charge up to 2 batteries at the same time. So here are the actual batteries, and one thing you might notice about them in comparison to the factory style battery. So this is the one that actually came out of that junk sports camera. It claims to be 900 milliamp hours, but it's actually only a 200 milliamp hour battery. But the shape and everything is just like the one that's in the DB power camera, so we can still use that as a comparison. You may notice how this one is a little rounded on the corners. So I figured, why not subject these batteries to the same tests I did in the previous video, where I used my Opus charger, which, before I forget, I better go and switch it back to 4.2 volts, because I was charging my 4.35 volt cells with it last. So this guy, and I took these alligator clips with these little things on the end to plug into the battery, to use this to charge it, because this can, of course, be used for charging and discharging, and it will tell you how much it puts in or how much it takes out. So we'll go ahead and hook up my my leads here. Now this is something you gotta be careful doing here. I did use this method to charge my camera's battery, because there's a whole lot faster method of charging versus charging within the camera itself. Yeah, the camera itself does it rather slow. So we'll make sure it's nice and clamped in, and because we're going to charge this up at a full amp. Yeah, in the video I used 500 milliamps of charging, but this time we're going to do it at a full amp. I will still, however, discharge at 500 milliamps, just to be more realistic. Make sure it's in there really good. Okay, So, now, sorry, this stuff out the way. We'll plug in our battery. And again, it's a little bit of a crude method of doing it, but it's the only way I can do it with my Opus charger. Perhaps I might have a better way of doing it in the future. I might pick up another one of these for cheap on Amazon or somewhere and just gut it and use one of these as terminals to interface with this guy. Who knows? For one thing, I'm curious to see how much we have in this. Yeah, guys, I am really considering taking one of these little guys and just gutting it. Use it to interface with my Opus charger. Oh, we have almost a full charge on these. They're sitting at, well, at least this one's sitting at 4.04 volts. So I'm going to stick this in there. Just got to be careful to make sure these don't touch and short each other out. I think that should do it right there. And I'm going to set this up to a 4,000. Now this is going to actually dial it down because we're pretty close to full charge as it is. So what I'm going to do is I'm going to finish charging this battery up. As you can see, I'm dialing it down as I mentioned. So again, we're going to charge this up to the full 4.2 volts, and then I'm going to run a discharge test on it to see what we can pull out of it. Just see if we can get 1350 milliamp hours out of it. This will be interesting. I can't remember exactly how much I paid for these batteries. I'll have to include it in the video description or in the as a title or something in the video. Okay, so while the first battery is charging, I have the second one here. Let's use my gram scale to weigh this battery. Now the other battery that I would use as a comparison is, of course, in my camera. So turn this on and let it calibrate. Okay, it's calibrated. So this battery weighs in at about 22 grams. The knockoff battery, again, says it's a 900 milliamp hour, but it's only a 200 milliamp hour battery. It weighs in at just 8.7 grams. Yeah, if I pull this battery out of the camera, which again, this one's rated for 1050 milliamp hours. Weighs in at 17.67. So 17.67 versus about 22 grams. Yeah, 21.85. So this one does in fact weigh more. And just for a quick moment, I'll pop it into the camera. And it does fit in there, even though it is a little bit different shape. Close this up. This little door is a little odd. Yeah, I don't have a memory card installed right now, but yeah, I'm thinking that this manufacturer may be true to their claim. And power this off. Yeah, it's interesting. The little indicator said it wasn't exactly full. I'll be honest with you guys. I've noticed with a lot of cameras that use lithium-ion batteries, some cameras their algorithms for how they handle discharging a lithium-ion cell kind of varies from manufacturer to manufacturer. For example, my Kodak ZI-8 cameras that I use on CubeComp MTDX, well, the ZI-8 that's in the wetter case, and the PlayTouch ZI-10, which goes on the porch, they seem to consider a fully discharged lithium-ion cell to be at about 3 volts. Okay. For example, my Midland XTC 280, I think it is, that other old action camera I have, all the DXG cameras that I have, and I'm thinking this as well, seem to consider a lithium-ion battery to be fully discharged, or at least the shutdown voltage to be at about 3.6, about 3.5 to 3.7 volts. So, not making full use of the battery's capacity. There's something interesting to note. Because I'm going to measure this battery's voltage. As mentioned, the camera just said it was not exactly full. It did have one bar missing. But this battery is sitting at, I'll read it to you, 4.03. So it has discharged just a little bit, but it's still pretty close to full. Now, the stock battery that this camera comes with, I can get about, roughly an hour to an hour and 20 minutes of runtime on HD 60 FPS, 1080p HD 60 FPS. So not terrible by any means, but of course could be better. So hopefully with these batteries I should be able to get better runtime. So enough of the random talk. I figured we're going to let this finish charging up, and then we'll run to the discharge test and see what we get. Okay, the battery has been fully charged. Just going to have a look at the charge it's put in. It's put in about 170 milliamp hours, so I wasn't expecting it to have to do a whole lot to top it off. So now we're going to switch over to discharge. And we're going to discharge at 500 milliamps. And let's see if we get around the rated 1350 milliamp hours out of this thing at half an amp of discharge. So I'll let this run and we'll resume when it gets done. Okay, so this battery has been discharging for about 22 minutes now, and we have pulled about 186 milliamp hours out of it. Current voltage of 3.95. And I figured to take opportunity to go ahead and talk about the charger. So the charger essentially takes in 5 volts from USB power. If you look at the bottom, it'll tell you 5 volts, 2 amps input. Output 4.2 volts, 0.75 amps X2 because it's a dual charger. However, time to give it a little test. And this battery here has charged up in it. This is the crap battery that came with that sports cam. You know, the little 200 milliamp hour piece of garbage that I don't really care about. Mouse is charging it up because I'm going to be doing a video soon about this battery again. And I figured it wouldn't be complete until I did a full charge rundown in my DB power camera, just to see how long I would, how much it would I'd get out of it as far as runtime. But I've noticed something that's a little concerning. So essentially, lithium-ion battery chargers are They're constant current and constant voltage power supplies, like a little lab bench power supply is what they are. Essentially, it's the equivalent of taking a lab bench power supply, setting it to 4.2 volts, and setting the maximum constant current value to, like, I don't know, 500 milliamps or 1 amp, or how much you're willing to put into the battery. And it starts out putting out maximum current, and as the voltage gets close to 4.2 volts, the power supply goes into constant voltage phase. In this phase, what it does is it starts to dial the current down to keep the voltage from going over 4.2 until you get to no current going in. That's how these things work. But this one here takes in 5 volts, and it says output of 4.2 volts. So when this thing takes in a battery that's not fully charged, the indicator will turn red. So pull this out. Let me measure the voltage on this battery. So we can get this in view. Make contact, that'd be great. This meter's a little weird sometimes. It has 4.08 volts in it, so what I might end up doing is I might end up popping this on the this battery on the Opus charger to get it up to 4.2. But here's the thing I noticed was when I had this thing plugged in here and the battery was low, I volt checked the other side to see what it was putting out, and it was putting out like 4.1 volts. But with it totally unloaded, it's putting out almost 4.5 volts, which is way over 4.2 volts. That's not good for a lithium-ion cell. Now, mind you, this thing, the way it behaves, it probably changes its behavior when it has a battery loaded in. But I mean, like right now, this battery's sitting at 4.1 volts. It's not even turning this red. I'm thinking there may be just a simple analog circuit in here. And some of these charger circuits, fresh out of China, can be a little dodgy, I'll be honest. Still putting out 4.47. Yeah, it's really, really weird. Let's unplug this for a moment. Now I'm curious to see, with the supply disconnected, if we get anything over here on this output. Oh, yes we do. We're getting like 1.42 volts out of it. So there's actually like some crosstalk between the two ports. Yeah, I'm not really sure about this little charger. The batteries that came with this, I'm thinking are going to be decent, but this charger, yeah, I'm not so sure. Now these chargers, now the batteries, if I remember right, I think the batteries were like $13. The whole kit was like $13. I'm gonna see if I can crack this open. Have a look inside, because I'm starting to get, I'll say I'm getting a little concerned. Okay, so this little pop of the screwdriver, this little piece here is coming off. So I'm curious to see what we have in here as far as circuitry goes. Okay, so I've went ahead and cracked open the charger, and what you're looking at is all that's inside there. It consists of two TC4056 charging circuits. These are the little integrated circuits here that are responsible for charging the cells, and they are constant current, constant voltage supplies. So they're a whole lot better than some of the dodgy circuits I've seen out there for charging lithium-ion batteries. But it's still a little concerning as to why I was seeing 4.5 volts on the terminals of this of this thing. Of course, now the meter was not really putting any load on it. I mean, the meter is typically like 10 meg ohm impedance is actually what mine says on it, so barely any load at all. But also a lithium-ion battery that is about fully charged should not be putting much of a load on it either. So I think for now I'm going to put this back together because I would think I'd need some more time to really analyze it just to get my final thoughts on it. But simple little charger. These two little integrated circuits, I mean, you can find them sometimes in power banks and stuff like that too. So I mean, that's all there is inside this thing. So I mean, if I really wanted to, I could modify this thing just to be like a little charging bay for interfacing with my Opus charger. All I would really have to do is desolder the two headers here because they're a through hole. All I have to do is remove this solder and they should come right out. And I could take them with some decent glue or adhesive, pop them back in here, and create some interface and hook up some interfacing wires to interface with this charger. Kind of like it's a bit, let's say a bit better constructed version of this. I'd have wires going from this dummy cell here with better terminals to interface with the actual charger. And I think it would probably make for a decent little setup. But then again, that would take away the convenience of being able to charge my action camera batteries anywhere there's a USB power source, such as my power bank. So yeah, I mean, it's either way. I mean, there's pros and cons. So that's the charger. Again, it was a little concerning to see higher than expected voltage on the output terminals, but then again, it's probably because the charger doesn't really know there's a battery there. And I'll be honest, again, if I didn't mention, this battery here was not overvolted by any means. I mean, it's sitting at, again, let me measure it, 4.08. So, matter of fact, I'm going to have to charge up some more before I can really even make an assessment with this battery in a later video. Okay, so the battery discharge here has been going for an hour and 15 minutes now. Still discharging at 500 milliamps. Current voltage is 3.73. We pulled 624 milliamp hours out so far, so things I think are looking pretty good. Now, with this thing, what I did is I popped this battery back in. It done the resting voltage fell down enough to where it would trigger the charge on this thing. It turned red for a moment. Yeah, I let it sit and charge for a while. Now it's turned blue. So now to see what the resting voltage is on this battery. I'll make sure it's not over 4.2. I'm going to pull it out. Our resting voltage is 4.17. Okay, so I'm thinking this is fine. Again, earlier it just seemed a little odd. I'll measure it again. This seemed a little odd earlier, seeing more than 4.2 volts measure at these terminals. I'll measure it again. Yeah, 4.46 right now. Which is rather interesting. Maybe it's part of the way that the device can detect if there's a battery in or not. As the battery will put some load on it and it will draw it down. That's my guess. I mean, the battery itself is not overcharged, so I'm thinking this is okay. It just seemed a little odd earlier. So we're gonna let this continue on and see what we get. Okay guys, the battery has finished discharging, and let's have a look at the results. It's now sitting at 3.3 volts. It's slowly rebounding. We pulled out just shy of 1,000 milliamp hours. So, not exactly 1350, but I can't really down it because, I mean, this battery is a little bit more hefty than the 1050 milliamp hour rated battery that came with this camera. And if I'm not mistaken, I think I got a little less out of it. I can't remember for sure what the exact number was. So now I'm going to actually charge this back up, and this time I'm going to charge it at 1 amp. Okay, let's see what we can put back into it. Okay, the battery has finished recharging, and let's have a look. Took an hour and 38 minutes to charge. Resting voltage is 4.19. 1066 milliamp hours is what went in. So, not exactly 1350 milliamp hours, but not too bad either. It is more than what the battery that came with this camera actually did. I think it was around the 850 to 900 milliamp hour range, somewhere in that area. Can't remember for sure, but it is a little bit of an improvement over that. But I mean, for like $14 for the set of batteries and the charger, you still can't go wrong. So next, we'll be repeating the same steps on the second battery. Okay, so now I'm going to repeat the previous steps on the second battery and see what we get out of it. So I'm going to connect it up. You gotta be careful doing it like this because you don't want these things to touch. Now here's an interesting observation. You may notice how my charger, briefly for a moment, showed 4.21 volts. You know, that makes me want to rethink about this this little charger over here. Now, to be honest, you know, 4.21, 4.22 may not going to be probably not going to be a very big deal, but you generally don't want to take these things over 4.2 volts. I'm going to discharge this on that 500 milliamps. And we'll see what we get. Okay guys, the second battery here has finished discharging. It's currently resting at about 3.36 volts. Only got 981 milliamp hours out of it at 500 milliamps discharge. So I'm thinking these batteries are more these are more likely 1000 milliamp hour batteries, and I'm saying that's because both of these batteries did perform very similar to each other, roughly 1000 milliamp hours, 1050, you know, something like that. They did actually do a little bit better than the factory battery that came with the DB Power camera. So, I mean, for $14, I mean, you can't complain. It's two extra decent batteries. It's definitely better than, you know, a knockoff like that right there, which I've already disassembled. I have a separate video on that. But, yeah. So, go ahead and switch back over to charge mode. And we're going to charge this up at 1 amp. And we'll see how it does. Okay, so this one just finished charging up. Well, actually it finished a little while ago. Anyways, Took an hour and a half to charge. Resting voltage is 4.17. 1030 milliamp hours. So very similar to the other one, to the one just like it. So I'm thinking these are more likely 1000 milliamp hour cells, or 1050, like the factory battery that came with the DV power camera. Now this one here did a lower number, and I think I've already mentioned like several times in this video, sorry guys, but this one here did a little bit lower number than that, so it is still an improvement. And I mean, for $14, I'd still say pretty decent. The charger though, I'm still a little on the fence on. Earlier in the video when I had metered this thing and was getting like 4.5 volts out of it, that was a little hairy. Anyways, that wraps up for the batteries. I'm gonna plug this thing. So that is an overview of the Camkong lithium-ion battery set and charger. Now I have not performed a test on the camera yet to see how long these will run the camera for, but what I'll do is, when I am able to, I'll put the time in the video description or something like that. Anyways, thanks for watching. Well guys, that's it for this one. But it doesn't have to be. There's plenty more videos on the channel to check out. Also, if you liked the video, please click the like button. And if you absolutely hated it, there is the alternative button as well. But yeah, please subscribe to the channel. I definitely appreciate it. And remember to click the bell so that we get notified of all updates. Also, if you're interested in things aside from computers and technology, check out my second channel. It's Camkong MTDX. Over there you'll find videos about weather, elevators, bicycling, and pretty much whatever else I figure out to upload. So yeah, anyways, hope you guys enjoyed this video, and thank you for your support.